This is easy digital signal processing homework for problem 2.56. For the system in figure P2.56, determine the output Yn when the input Xn is equals delta n, and h of e to the j omega is an ideal low-pass filter is indicated. You can see that h of e to j omega is when omega, absolute value of omega is smaller than pi over 2, the value of the h is 1, and value is 0 otherwise. Because x of n equals delta n, so the Fourier transformation of xn is 1. And for the first step, we can get w of e to the j omega equals h of e to the j omega times x of e to the j omega. Because x of e to the j omega equals 1, so w of e to the j omega equals h of e to the j omega. And then the system separated in two ways. In the upper way, the signal x of w of n times the signal minus 1 to the n. Because minus 1 to the n equals e to the minus j omega n, we can get that y of e to j omega equals w of e to j omega plus w of e to the j times omega minus pi, because of the shift theorem. So in this way, this equation equals h of e to the j omega plus h of e to the j times omega minus pi. Due to the shift theorem, we can get h of e to the j times omega minus pi is like this way. So it's obvious that this signal fill the gap when h of e to the j omega equals 0. So overall, the system output y of e to the j omega is 1. And we can get Yn is delta n. So that's a solution to the problem 2.56.